is Hannah Hayes, and I am a graduate student working under Dr. Peter Kroll. This project is the tunable synthesis of flexible polysiloxane aerogels for oil-water separation. SiCO-based aerogels have a wide range of applications due to their low density and micropore structure. Typically, these aerogels are brittle. However, using this method, they are compressible and have flexibility. The mechanical properties that are observed of these materials are related to the ratio of the PMHS to VMDMS use. The motivation for this project is due to the limitations of the volume and reusability of the traditional oil-water separation methods. The low density and flexibility of these gels reduce the issues that are seen. This two-step synthesis method can be tailored to improve hydrophobic and oilophilia properties using surface modifications and ratios of the precursors. The gels are prepared through first modifying the PMHS with VMDMS through a hydrosilylation reaction. The gel is then condensed with water, benzyl alcohol is added for surface modification, and washed and ambiently dried to produce the ambigel. Analysis of the modified PMHS from the first step shows successful hydrosilylation reaction in the FTIR and proton NMR from the disappearance of the SiH and vinyl groups shown here. The SiH bond in the PMHS is no longer seen in the modified PMHS, and in the NMR, this SiH bond is no longer seen in the modified PMHS. Thermal gravimetric analysis shows that the modified polymer is more thermally stable to a higher temperature due to the later onset temperature and higher mass retention. The DTG shows two mass loss processes, first loss of oligomers and then gaseous product. Typically, these are methane and hydrogen. Solubility studies were conducted to find a suitable solvent that allowed for better tailoring of the benzyl alcohol modification. The benzyl alcohol was previously used as both the solvent and modifier of the surface. Finding a different solvent would allow us to specifically add in known amounts of benzyl alcohol to figure out how much of the surface is actually being modified. The goal of this was to find a suitable solvent that does not react with the modified PMHS and instead is only used as the solvent. The FTIR can be used to show any change in functional groups. So for example here, the acetone, there is not a large change in the ratio of the SiOC to SiOSi, wherein the ethanol there is. If there is an increase in the amount of SiOSi, this indicates that a condensation reaction has occurred, and therefore it is not a suitable solvent to be used. TGA analysis of the ambigel that was produced shows a mass gain under nitrogen and not under argon. Further investigation must be used to explore the phenomenon that is occurring here. The FTIR does not show a significant difference in the functional groups under argon and nitrogen. However, what is seen is that there is a loss of these carbon and hydrogen groups, which is expected from the loss of methane and hydrogen. The FTIR of the sample A and sample B prepared do not show a significant change in functional groups, even though there is a different ratio of PMHS to VMDMS used. These images shown here show the water droplet on the surface of the gel prepared, and here it is shown that the oil was absorbed into the gel. The water contact angle was calculated to be greater than 160 degrees. Anything greater than 90 is characterized as being hydrophobic. The FTIR was compared for the two precursors, the PMHS, VMDMS, the modified PMHS, which is the intermediate, as well as the ambigel. These functional groups are as expected from literature. In the future, we are hoping to look at more ratios of PMHS to VMDMS, use different solvents to tailor the surface benzyl modifications that are occurring, use different hydrophobic modifiers, compressibility studies, water-oil separation test, and SEM, as shown in these images below from literature, as well as porosity measurements. In summary, the TGA showed that the modified PMHS had a thermal stability to a higher temperature than its precursor. The FTIR and proton NMR of the modified PMHS showed successful hydrosilylation reaction. The solubility studies indicated that acetone may be used as a solvent in these gels. A high water contact angle was observed, which shows the hydrophobicity of these gels. The compressibility and flexibility of these gels was seen, as well as the oleophilic properties.